Now the next topic is factor theorem. Let us first see the statement of this theorem. If p of x is a polynomial of degree n is greater or equals to 1 and is a is any real number, then x minus a is a factor of p of x if pa is equals to 0, and if pa is equals to 0, then this x minus a is a factor of p of x. Okay, now we will understand this factor theorem by taking one example. The last question of exercise 2.3 is similar to this theorem, okay, but I will take one example. If we divide 16 by 2, 2 it's a 16, remainder is coming 0. So if remainder is 0, okay, then 2 is a factor of 16, okay, or if 2 is a factor of 16, then remainder will be 0, okay. Similarly, if px is a polynomial and x minus a, px is a polynomial and x minus a is a factor of this polynomial, then p of a is equals to 0. The remainder theorem and factor theorem are very close to each other, means they are nearly equal same. The only difference is in factor theorem, factor word means the remainder is 0, okay, that is the only difference, right? So if x minus a is a factor of any polynomial, it means when you find 0 of this polynomial and when you put value here as we used to do in remainder theorem, so in remainder theorem we used to get remainder either 0 or any other number, but in factor theorem, since it is a factor, so you'll always get 0, okay. After putting the value, we will always get 0, means if the remainder is 0, then the number is a factor of the given polynomial, and vice versa. If value is 0, then it is, if it is a factor, then value will be 0. If value is 0, then it is a factor of p of x, okay. Means if 16 divided by 2, if 2 is a factor of 16, it means we'll get remainder 0. If remainder is 0, when we divide 16 by 2, then 2 is a factor of 16. Understood? So this is a factor theorem. Now, which type of questions you will get here? So we will take one example. Examine whether this x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. We are given two polynomials and we have to check whether this x plus 2 is a factor of this polynomial as well as this polynomial, okay, whether it is a factor or not. So if x plus 2 is a factor of this polynomial, then when we divide this polynomial by x plus 2, we'll get remainder 0, okay. This is the meaning of this is the factor theorem, okay. So first what we will do, this is our required polynomial, x cube plus 3x square plus 5x plus 6. Now we will find 0 of x plus 2. So 0 of x plus 2 is, x plus 2 will equate 0 minus 2. So 0 of x plus 2 is minus 2. You will find that remainder theorem and factor theorem, sometimes you will feel that remainder theorem and factor theorems are not different, they are actually same. Of course they are same, but the only difference is in factor theorem, since it is a factor, so the remainder will always be 0. This is the only difference, okay. So 0 of x plus 2 is minus 2. Now we'll put the value of x here in the polynomial, and if it is coming 0, it means it is a factor, okay. So when you put x equals to minus 2, you will get minus 2 cube plus 3 minus 2 square plus 5 multiplied by minus 2 plus 6. Simplify. Minus 2 cube is minus 8. Plus minus 2 square is 4. 4 3 is 12. Minus 5 2 is 10. Plus 6. So 12 plus 6 is 18. And minus 8 minus 10 is 18 is equals to 0. See, we are getting value 0. It means remainder is 0. Okay. Remainder is 0. It means this x plus, so we will write by factor theorem, x plus 2 is a factor of this polynomial x cube plus 3x square plus 5x plus 6. Okay, if the remainder is not 0, then it is not a factor. Simple. Now we are given one more polynomial. We also need to check this x plus 2 is also a factor of this 2x plus 1 or 2x plus 4 or not. So the next polynomial we are given is, so again we are given this polynomial 2x plus 4, and we have to check whether x plus 2. So we will find 0 of x plus 2, which is minus 2, and we'll put here. So p minus 2, 2 multiplied by minus 2 plus 4, it means minus 4 plus 4, 0. See, again we are getting 0. It means this x plus 2 is also a factor of 2x plus 4. Okay. Now the next type of question is this. In the next exercise 2.4, you will get 3 types of question. The first type of question, which we have already done, okay, check whether the given polynomial is a factor of another polynomial. This is type 1 question. This is our second type of question, where we have to find the value of k, and it is given that x minus 1 is a factor. Okay, it is given, we need not to check, it is given that x minus 1 is a factor of this one. Okay, and third type of question is factorized, that we will do later. So now let us see this type 2 question. So in this question we are given that this x minus 1 is a factor of this polynomial, means we are given that 2 is a factor of 16. So if 2 is a factor of 16, it means 2 divides 16 completely, or when we divide this 16 by 2, we'll get remainder 0. Okay, so here x minus 1 is a factor of this term, means when we divide this polynomial by x minus 1, we'll get remainder 0. Or when we put x equals 2, we'll find 0 here. So when we put x equals to 1 in this polynomial, we will get 0. Okay, so meaning of factor is, so since we are given that x minus 1 is a factor of this, so we will write as this x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Now we will write the meaning of this factor. Factor means when we put from here, we will find x equals to 1. So when we put x equals to 1 here, we will get 0. Means when we put in this polynomial, when we put x equals to 1, we will get 0. Okay, here we will get 0. Okay, we know that it's a factor, right? So p1 is 0. p1 means when x is 1. So 4, 1 cube plus 3, 1 square minus 4 multiplied by 1 plus k is equals to 0. Simplify. 4 multiplied by 1 plus 3 multiplied by 1 minus 4 multiplied by 1 is 4 plus k equals to 0. 4 plus 3 minus 4 plus k equals to 0. This 4 and 4 will cancel out. So we'll get 3 plus k equals to 0. It means k equals to minus 3. So here k is minus 3. So these are the 2 types of questions which will means the same type of question we will solve in the exercise. The third type of question we will solve later, but first we will see this exercise 2.4. Question number 1, 2, 3 are completely based on this factor theorem and this type 1 type 2 questions. Okay, so one question we'll see from each. So exercise 2.4, question number 1 is determine Determine which of the following polynomial has x plus 1 a factor. Means we are given 4 polynomials and we have to check x plus 1 is a factor of these polynomials or not. Okay, x plus 1 is a factor of this polynomial. So factor means when we put the value, we'll get 0. If we are getting 0, then it's a factor. If we don't get 0, then it is not a factor. Okay, so in each case, we'll put x equals to, we have x plus 1. So we will find 0. 0 of x plus 1 is how much? Minus 1. So in each question, in each part of this question, we'll put x equals to minus 1. And if it is coming 0, if the value comes 0, it means this x plus 1 is a factor of the given polynomial. Okay. First I will take the first one only. So the first polynomial is x cube plus x square plus x plus 1. Now put x equals to minus 1 here. So when you put minus 1, you will get minus 1 cube plus minus 1 square plus minus 1 plus 1. Minus 1 cube is minus 1, minus 1 square is plus 1, and this plus minus is minus, and this plus 1. So minus 1 is minus 2, and 1 plus 1 is 2. See, we are getting 0. It means x plus 1 is a factor of this polynomial x cube plus x square plus x plus 1. Okay. Now you find whether this x plus 1 is also factor of this second question and this third one. I will solve the fourth one. So the same value minus 1, because we have to check whether x plus 1 is a factor of this fourth polynomial or not. So what we will do, in this polynomial we'll put x equals to minus 1. So the polynomial is x cube minus x square minus within bracket 2 plus root 2x plus root 2. We have to check whether this x plus 1 is a factor or not. So we'll find it's 0, means minus 1 we'll put here. So when you put minus 1, you'll get minus 1 cube minus minus 1 square minus 2 plus root 2 multiplied by minus 1 plus root 2. So minus 1 cube is minus 1 minus minus 1 square is plus 1, and this minus plus minus minus, and then here we'll multiply each number by, we'll multiply each digit by this minus 1. So we'll get minus 2 minus root 2 plus root 2. Now we will open this bracket. So when you open the bracket, this minus minus plus 2 minus minus plus root 2, and this plus root 2. Minus 1 minus 2 plus 2 plus root 2 2 root 2. This 2 and 2 will cancel out, so we'll get 2 root 2, which is not 0. Okay, so we'll write x plus 1 is not a factor of this x cube minus x square minus 2 plus root 2x plus root 2. Okay. Now question number 2 is, use the factor theorem to determine whether gx is a factor of px in each of the following cases. The question is same. The only thing is they have given a particular name for this polynomial. We have to check whether this gx, this polynomial, is a factor of this one or not. So the procedure is same. From this polynomial, we have to check whether this is a factor of this one. So from here we will find 0 and we'll put the value here. If the answer is 0, then this will be the factor of this polynomial. Okay, so there are 3 questions. You solve first and second. I will solve the third one. So we have to check whether this gx. So we'll find 0 of this x minus 1. So how to find 0? By equating 0. So 0 of x minus 3 is 3. Now we'll put the value here. In this polynomial, we'll find the value of this polynomial at point 3. So 3 cube minus 4 3 square plus 3 plus 6. So here 27 minus 3 3s are 9, 9 4s are 36 plus 3 plus 6. So here 23 plus 27 plus 3 is 30, 30 plus 6 is 36, 36 and this minus 36 is 0. So Are we getting 0? Yes, we are getting 0. It means this x minus 3, which is gx. So we will write this gx is a factor of this polynomial p of x. That's it. Okay. So similarly, you solve the first and second one. And now we'll move to the next question of this exercise, where we have to find the value of k. Okay. Find k if x minus 1 is a factor of p of x in each of the following. Means again we are given 4 polynomials, and we have to check whether this x minus, no, not we have to check, it is given, or it is also given that x minus 1 is a factor. It is a factor and we have to find k. So there are 4 questions. X square plus x plus k, this is first one. 2x square plus kx plus root 2, this is second one. And kx square minus root 2x plus 1, this is third one. And kx square minus 3x plus k. So I will solve this third one. Okay, you solve first, second and fourth. So the third polynomial is kx square minus root 2x plus 1, and it is given that x minus 1 is a factor of this polynomial p of x. It means we can put x equals to 1 in p of x. Okay, so when you put this x equals to 1 in this polynomial, you will get 0 because it is a factor. So p1 is 0. p1 means when you put x equals to 1. So let's put, so k1 square minus root 2 multiplied by 1 plus 1 equals to 0. So k minus root 2 plus 1 is equals to 0. So here we'll get k equals to, when you transpose this root, minus root 2 will become plus root 2 and minus plus 1 will become minus 1. So this is the value of k. Okay. Now you solve the remaining one. I will write the answers here so that you can check. So here the value of k, you will get minus 2. Here you will get the value of k minus 2 plus, or this can also be written as minus 2 minus root 2. Okay. And this third we have already done. And in the fourth part, you will get k equals to 3 by 2.